Welcome to June 20th's LeetCode Challenge, Swim in Rising Water. On an n by n grid, each square grid ij represents elevation at that point ij. Now rain starts to fall. At time t, the depth of water is everywhere as t. You can swim from a square to another square for directionally adjacent square, if and only if the elevation of both squares individually are at most t. You can swim infinite distance at time zero. Of course, you must stay within the boundaries of the grid during your swim. You should start at the top. You start at the top left square, 0, 0. What is the least time you could reach the bottom right square at n-1, n-1 coordinates? Alright, so let's kind of follow this example. This one's a bit easy. Let's follow example number 2. So you're given n by n matrix here, and you want to start at this square, and you want to reach this square. Each time t that goes by, the water level rises up by 1, and you're able to travel if the square you're on is equal or less than the square adjacent directionally adjacent to you. So at point number 0, you can't go anywhere. At time t equals to 1, this becomes 1, so therefore you're able to travel to square 1. Now that you're here, you can't travel here anywhere else, except for you have to wait until time t equals 2, where you're able to travel this way. Likewise, at time t equals 3, you could travel here. At times t equals to 4, you could travel here. At time t equals to 5, you could travel downwards. Oops. And then you're stuck here, right? Because the next minimum level you can wait to is time t equals 16, you could travel downwards. And then from here, you can travel, everything is less than yourself, so you can travel automatically directly to the very end. So the minimum time you have to wait for the water level to rise to a point where you could reach the square n-1 n-1 would be t equals 16, which is the output. So this is the path that you're going to take all the way across, down to 16, take all the way to the left, to 12, down to 10, and all the way to the right till 6. And you wait till t equals 16 to be able to travel that distance. So let's go about solving this. There's a hint here telling you to use Dijkstra's algorithm of binary search for best time efficiency. We might use a little bit of Dijkstra's algorithm here, but there's something called, I believe, flood filling algorithm that you could use. It's called a flood filling algorithm. Where like you have to wait. It's a search algorithm simply commonly used in like games such as Minesweeper or Go, where you're able to just fill up an algorithm, search through a grid easily at a fast, efficient, or time complexity. So let's start off with what we need to do in order to solve this. So luckily, this is for us. We have a square that's n by n. So what we could do is to find the n, so which is the length of the grid. Next thing we should need is a let's see, an output equal to 0. Initialize that for now. What else do you need? So in order to use the flood filling algorithm or a Dijkstra's algorithm, we need a heap, actually a minimum priority queue. So in order to do that, we're just gonna start running a heap out here. So heap equals we'll make the heap have these following properties. So we're gonna fill it up with a grid at index 0, 0. That's where we're starting off. 0. And then it's also going to have the coordinates as well. Alright, next we have the heap. So for Dijkstra's algorithm or flood algorithm, we need to know where we have visited. So the areas we have visited. So let's go to let's develop a variable called visited I should say. Not visit is shorter. Which is going to be a set, because you don't want to have duplicates in there, because you don't want to visit a place twice. Then we're going to add our first visit area, which is our starting point, which is add 0 to that. So we develop our length of the grid, which is n. We have defined output yet, which is initialized to 0. Then we have our heap, which has our grid in the first area, and then we have our 2 coordinates. We have a set developed in order to keep track of where our visited points are. We added our first point in, which is visited at point 0, 0. So we'll show how we're going to travel through this algorithm. So here's how we're going to traverse through the Dijkstra's algorithm, or the flood filling algorithm. So while the heap is true, while the heap is not empty, what do we want? We want to assign some variables to h, I, j. So we want to know 3 things about it. So we want to know that we want to make sure that the heap q is the first thing we want to do is pop it off. Heap pop. Heap. Next thing, what do we want to do? We want to update results output to the max between output and our heap currently that's been popped. Next thing we want to do, so if the index I is equal to n minus 1, which is our bottom right corner, I and j, I should say. So if we manage to reach our bottom right corner, then return the output because we're done our traversal. All right, that's the first part. So if we pop off our heap from the top and we find the maximum between whatever's in the heap. So how are we going to store these values? What do we push into the heap? So the conditions for pushing it into the heap to begin with is we're going to define for x, y in the four directional routes you could travel. So it'd be I plus 1, comma j. Next thing will be I minus 1, comma j. It would be I j plus 1, comma I, comma j minus 1. So these are all the directions we could travel. So we could travel up ones, down 1, right 1, left 1s. 4 direction we could travel. So for all these conditions for x and y, what we're going to do, so if x is greater or equal to 0, which is within the ranges of n, and so we need to make sure that our x direction is within our coordinates of between 0 to n, and we also need to know that y is within our grid as well, equal y less than n, and our xy coordinate, the cell that we that we are looking for, is not visited yet, not visited. Then what we're gonna do? So for xy coordinates in the up, down, left, right direction, if x is within a grid and y is within a grid, and x and y are not in the visited set, then what we're gonna do is we're gonna add the coordinates. So we have to say that we visited it. So add x comma y, and then we also have to push it into the heap. Heap push, and we want to push that into the heap for our grid. X. All right. So that seems to be. Oh, I think this needs to be within it. Yes. Heap pop ij. I see. That's our heap. submit it. Alright, accepted. So this is basically using the flood filling algorithm. So the time and space complexity would be big of n squared, because it is a grid, times log n. So where n is the length of the grid, and for each pop and each heap, each insert and each extract, each pop and each push will take n squared times into the heap. And for space complexity, it's n squared. So we have, that's just n squared for the heap. Right? That's pretty much it. Alright. It is if you're familiar with the flood filling algorithm or Dijkstra's searching algorithm, then it shouldn't be fine. But I think this is labeled as a hard question because you learn Dijkstra's algorithm at a very later stage in any type of learning algorithm. So there you go. Have a nice day.